For our next example, we have x prime is equal to matrix A times x. So A is 1, 0, 0, 0, 3, 1, 0, negative 1, 1. So the first thing I need to do is find the determinant of A minus lambda I. So here's our matrix A. Lambda I is just the identity matrix with lambdas down the diagonal. So A minus lambda I would give me 1 minus lambda 0, 0, 0, 3 minus lambda 1, 0, negative 1, 1 minus lambda. So I'm going to expand this about the top row. So I get 1 minus lambda times 3 minus lambda 1, negative 1, 1 minus lambda. And then minus 0 times the next, and then plus 0 times the last one. So these are just going to give me 0, so I don't have to worry about them. So I'm just going to expand that out. I get 1 minus lambda. And then that determinant, 3 minus lambda times 1 minus lambda, minus negative 1 times 1, so I end up with plus 1. So I'm going to FOIL that out. I get 3 minus 3 lambda minus lambda plus lambda squared plus 1. And we know we want to have this thing set equal to 0. So I get lambda squared minus 4 lambda plus 4. And then that is just 1 minus lambda, and this is a double root lambda minus 2 squared. So I have one distinct root, lambda 1 is equal to 1, and then I have repeated roots. So lambda 2 is equal to 2, which is the same as lambda 3. Alright, now I want to find my K1. So lambda 1 is equal to 1. And the first I need A minus lambda I. So since lambda is 1, A minus lambda I, here's my A, is going to yield 0, 0, 0, 0, 2, 1, 0, negative 1, 0. Just subtracting 1 off the diagonals. And then we have our vector K, and it equals 0. So when I multiply it out, the first thing I get 0k1 plus 0k2 plus 0k3 is equal to 0. So it tells me there's an infinite amount of solutions. My second row, I get 0k1 plus 2k2 plus k3 is equal to 0. And then my third row, I get 0k1 minus k2 plus 0k3 is equal to 0. So this last row tells me that k2 is equal to 0. The first row, again, it's infinite solutions, and the second row, I get 2k2 is equal to k3. So therefore, k3 is equal to 0, because k2 is 0. So K2 is 0, K3 is 0, K1 is anything. And again, because we want to pick things that are just nice to deal with, we're going to make K1 equal to 1. So K is going to be 1, 0, 0. Alright, now I need to find K2. And lambda 2 was equal to 2. So my A minus lambda I is I'm subtracting 2 from all the entries down the diagonal from the original vector. And that would give me a negative 1, 0, 0, 0, 1, 1, 0, negative 1, negative 1. And I'm multiplying that by vector K. So I can find K2. And that equals 0, 0, 0. So I'm going to do that matrix multiplication. I get negative K1 plus 0 K2 plus 0 K3 is equal to 0. So K1 is 0. And then the next row, I get 0 K1 plus K2 plus K3 equals 0. So K2 is equal to a negative of K3. And then the last one, I get 0 K1 minus K2 minus K3 is equal to 0. So K2 is equal to a negative K3. So again, just to make life simple, we know that K2, we're going to just use it for, well, we know 0 is K1. We'll use 1 for